All right, so this is week 3. So if you go to Schoology, on week 3, you'll see that the topic is going to be solving linear equations in y equals mx plus b format. So that's actually the first thing we want to write down. So on your guided notes where it says slope-intercept form, next to that you want to put y equals, and what did I just say it was? Yep, mx plus b. Okay. What does the m's represent? Yep, that's your slope. And what about the b? That's your y-intercept. Okay, so I'm going to go through when you're writing an equation in y equals mx plus b, what changes and what doesn't change. So as far as what doesn't change, the x variable doesn't change. That's going to stay exactly the same. Okay. So I'm going to highlight in green things that change. Okay. X stays as x. The y stays as y. Okay. The two things that are going to change are the m and the b. Okay, so the two things that I highlighted in green, you have to fill in a number for those two things. That number will be given to you in some way when they give you the problem. Okay, so next to slope, just so we remember the letter, I'm going to put an m next to that. So slope is your m. And y-intercept is b. We're going to talk about, because we're going to do some word problems, I'm going to give you guys some hints at what kind of words do you look for that mean slope, and what words can you look for that mean y-intercept. It's a couple hints here, but I'm going to give you guys some more hints about that. Okay? So let's actually go to the last page where on your guided notes it says keywords for y-intercept and keywords for slope. People see that page? You get that? Okay. So let's go through some of the words that you're going to see. A y-intercept is something that only happens one time. So if you see a phrase like one time fee, okay, if you're doing a word problem, it's a one-time fee, that's a hint that that's the y-intercept. What else? Okay. A lot of the problems that you're going to do in your notes, they talk about some kind of fee. All right. Activation fee, service, a one-time service fee, a one-time membership fee. Those are all fees. Like if you join a club and you pay a membership fee to join, that's usually just one time, right? The fee to join it. Fee. Let me see if there's anything other than fee. How about one-time fee? Another thing you might see is one-time cost. That's kind of the same thing as saying a one-time fee. One-time cost. Any kind of starting or initial value. Okay, let's say I was measuring, I don't know, the depth of a lake. And I said at the beginning of the summer, the depth of the lake was 20 feet. The initial value at the beginning of the summer was 20 feet. That would be a y-intercept in my equation, okay? Because the depth was 20 feet, and then maybe if it didn't rain all summer, the depth of the lake just kept dropping and dropping and dropping. So anytime that's an initial fee, starting value, initial value, those are all hints that they are the y-intercept. Okay, what are some words that mean slope? Okay. If you see the word per, right, like the cost to publish the yearbook is $20 per book. That's not a one-time fee. If the school is printing a yearbook and it costs them $20 per book, they have to pay $20 every time they print them. So that's a slope, something that keeps happening. They're printing shirts for Spirit Day. The shirts are $5 per shirt. There's another example where they use the word per. Escape rooms, $28 per person. It's not just a one-time fee of $28. You have to pay every time a person joins the escape room another $28. Okay, I think almost every problem you're going to see has the word per in it for the slope. Okay, we're just saying something that happens over and over. So like if I said to you, you know, you're gonna lose, or you're gonna gain 5 points for every extra credit assignment you do. That's not a one-time thing. That's 5 points every single time. That happens over and over. So if I gave you 5 points every time you do an extra credit assignment, 5 would be your slope. 5 extra points per assignment that you do. 5 extra points per assignment. Okay. All right, so let's try the 2-word problems and see if we can figure out our variables. Okay. So it says I think this is the first word problem in your packet. A city parking garage charges a flat rate of $3.50 per hour for each additional hour. Write a linear model, that means y equals mx plus b, of this situation. Okay. What did we say on the first page of notes happens to y? Yep. Y is just going to stay as y, so we're not going to change that at all. What did we say happens to x? Yep.
It goes to
so check that first page.
sorry.
Double check.
X stays as X.
X stays as x. Okay, now the m. What did we say m represents? That's your slope. And is there a word in this problem that indicates there's 2 numbers? Which one of these is the slope? What is it? Right, it has per after it. Remember, when we talk about slope, one word that you're going to see near the number for the slope is per. Something that happens over and over. Do you pay 50 cents one time? No. You pay 50 cents for every single hour you're parked there. So 50 cents is your slope, which means what number is going to be your B? $3. Okay. $3 is your B because that $3 is a one-time fee. You do not pay the $3 over and over. You pay it for the first 2 hours, and you never have to pay $3 again. So it's a little more expensive to park for just the 2 hours, but then after that, it's only 50 cents an hour. What's the equation that we fill all these into?
Y equals mx plus b.
Yep, y equals mx plus b. Okay. And now follow your directions Right there, yeah. Pencil? Yes. Okay, so y stays as y, x stays as x. And we're going to fill in the m and the b. Okay, what am I filling in for m? What is it?
0.50.
Yep, 0.50. And what am I filling in for b? $3. That's what they're looking for the first problem. So now, if you tell me like how many hours you parked, we could plug that in and we could do the calculation. Like if you parked, you know, a certain amount of hours, but that's the equation that they want. Any question on that? Okay, so let's look at the next one. So this one says, a feather blew out of a bird nest that was 10 feet in the air, and it drifted to the ground at a rate of 2 feet per second. Write an equation that represents the relationship between the height of the feather and the number of seconds that it's been falling. So the more time that happens, what happens to the height of the feather? It's going down. Okay, it's going to eventually hit the ground. Okay, what happens with the y? Yeah, the y stays as y. So we don't do anything to that. What happens to the x? Yep, stays as x. Now, m is the slope. Do we see out of our two numbers, 2 and 10, which one of those numbers would be the slope? The 2, because it's not like the feather just falls 2 feet. No, the feather falls 2 feet every second. So every second it drops another 2 feet. So that's your slope. And which number would be your y-intercept? 10. And that's because the y-intercept, think of it as like the initial height of the feather. Where did the feather start at? How high in the air was the feather? At the beginning.
10 feet.
Yeah, that's the initial value of the feather, and that's a one-time number. It never is going to hit 10 feet again. It starts at 10 feet, and then it falls. Okay? So what's the equation that we're going to fill everything into again? Yeah?
Y equals mx plus b.
Y equals mx plus b.
Could I give you the equation?
Sure. What do you think it is?
Y equals 2x plus 10.
Plus 10. Here's your equation. So now let's say you plugged in a 1. After 1 second, how many feet will the feather have dropped after 1 second?
So we drop 2 feet.
2 feet. And it started at 10 feet, and it's going to drop 2 feet. So how high will the feather be after 1 second?
8 feet.
8 feet. And look what happens if you plug in a 1. What's 2 times 1? 2. What's 2 plus 10? 12. Uh-oh. The feather went up 2 feet.
Oh, you said times or plus?
No, we did 2 times 1 is 2. 2 plus 10 is 12. So we got 12. We should have gotten 8. Right. Because you got to be careful. The feather is drifting to the ground. Okay, what does that mean? Drifting to the ground means it's going down. When you see a phrase like that, you need to make sure your slope is negative. Right? Falling, drifting to the ground. I think there's a problem in the packet about the lake receding. That means that the water level is dropping. I give you a hint that recede means negative. Let's check if we plug in 1 now. What's negative 2 times 1? And what's, if you take 10 and you subtract 2 from it, what do you get? 8. So now the formula is correct. Okay, so you got to pay attention if your slope is something about like an increase, it should be positive. or if it's a decrease, it would be negative. Okay. Any questions on that? All right, so I think, yeah, and that was it. So with slope, just be careful with positive versus negative. So what if you had an example and it said something about, let's see, it costs you $2 per movie that you watch. $2 per movie. Do you think that would be positive or negative? It's going to cost you more and more money for each movie you watch.
So you're gonna drop your money in your bank account.
Well, your bank account, we'll look at it as how much money you're spending. Is it going to go up or is it going to go down?
It's gonna go up.
It's going up. If it costs you $2 per movie, every movie you watch is going to cost you more and more money. So if you're writing a formula for how much money you're spending, it's a positive slope. It's going to be going up. What about a karate dojo charges $50 per month for classes, and you're writing a formula for how much money it costs you to do karate? Is the amount of money you're spending going up or going down? What do you think? It's what?
For what?
Is it going up or is it going down? Yeah, it's going up, right? The amount of money, if it costs you $50 every month for karate classes, the amount of money that you spend is going to go up if you keep going to karate. The amount of money you spend isn't going to go down if you keep taking classes. Right. So that's the topic for this week. So you do have a little bit of time left. You can work on the MCAS question. You don't have to start the IXL today, but you could also work on the worksheet that's in your packet. And then we've got the diagnostics, but that's not till Friday.